So far, every example that we've looked at passed part 1, namely the degree of the numerator was less than the degree of the denominator. But that's not the case in this example. So the degree of the numerator is 4, and the degree of the denominator is 3. So we're in trouble. That is not less than the degree of the denominator, which is 3. Boo. So then what do we do? Well, then we have to use the polynomial long division. Indeed. So we will take x to the 4th minus 5x cubed plus 6x squared plus 0x. You put in a placeholder for any term that's missing as you work your way down. And we'll divide that by x cubed minus 3x squared. We don't need to go any further than that. Technically, it's 0x plus 0, but it's irrelevant, so we don't need it. Okay, so I need to figure out what I need to multiply x cubed by in order to get x to the 4th. Well, that's obvious. It's an x term. And you put it over the x term here. X times x cubed is x to the 4th. X times 3x squared is minus 3x cubed. So those terms would line up, and we subtract everything. So x to the 4th minus x to the 4th is 0. Negative 5x to the 3rd minus a negative, so that's plus 3x to the 3rd, is negative 2x to the 3rd. Bring the 6x squared down and go again. We've done this before, so it should look familiar. So now we do minus 2, because minus 2 times x cubed would be minus 2x cubed. Minus 2 times negative 3x squared is plus 6x squared. So then everything cancels. You're left with 0 here. So 0, 0. You do have a remainder of negative 18. That's your remainder. All right, so let's rewrite our integral. So all of this is still step 1. So when I rewrite my integral, I'm going to rewrite my integral as, instead of x to the 4th minus all that stuff, I'm going to write x minus 2 minus 18 over my denominator. Okay, but step 2. So now we're done with step 1. Step 1, we've made sure the degree of the numerator is less than the degree of the denominator. See, this one has degree 0. And this one is degree 3. So yay. I guess I should say equals 0. Degree equals 0, degree equals 3. Woot. So now we're set. So now step 1 is finally done. Step 2. Step 2 is we're going to factor that. So it's x minus 2 minus 18 over. There's an x squared here. So x squared times x minus 3 dx. So the part that needs the partial fraction decomposition is actually this piece. I mean, x minus 2 is easy. We know how to integrate that, no problem. So I need a partial fraction decomposition for this piece right here. I'm going to make a note of it. Okay, so let's go over to the side and figure it out. We can do it kind of all over here. I'm going to kind of separate everything, right? So I'll do the partial fractions over here on the left. Okay, so let's think here. I don't need to worry about the x minus 2. That's totally fine. So what I really need is the 18 over x squared times x minus 3, right? So if I wrote 18, oh, technically negative 18. Yeah, I'll just leave it positive 18 and I'll distribute. Nah, I'll do negative 18. I take it back. All right, so I'm just pondering that. Nah, I'll do positive. I'll just, when I do this, I'll just distribute the negative to everything. It'll be fine. So 18 over x squared over x minus 3 equals a over x minus 3. Let's get that constant one out of the way. Plus, and then I have a bx plus c over x squared. That'll work, right? Okay, so then let's think here. I want to multiply everything by that common denominator of x squared times x minus 3. So over here on the left, I'll have nothing left but 18, which was my goal. I'll have a times x squared. And then I'll have bx plus c times x minus 3. Like that. Okay. Well, again, we have a couple options available to us on how we want to do this. We could substitute in 0, substitute in 3. Those would be some good choices. We could also use the other method of distributing. So either way, I think I'm going to do the other method just to give you guys an example of one that's not so hard. So this is ax squared plus, actually I don't need to write it, well, I'll leave it like that. And then bx squared minus 3bx plus cx minus 3c, like that. Agreed? Right? So ax squared, bx squared, I just FOILed this essentially. So now look over here at the x squared terms, right? Well, heck, look at the constant terms for starters, right? So c can be solved for right away because the only constant terms I have over here is negative 3c. So negative 3c must be equal to 18. So c is negative 6. That's done. I know c is negative 6. I'm going to highlight it. Then what else do I know? I know the two linear terms in the middle. Let me try to get those. The b and the c. But I know c now. So, and I know that there's no linear term over here. So it'd be 0x. So negative 3b plus c must be equal to 0. But I know c is negative 6. So that's negative 3b plus negative 6 is equal to 0. That means negative 3b is equal to 6. And that means b is equal to negative 2. Done with that one. Okay, now that I know that, I know those two, look at the a and b terms. Look at these two right here, a and b. They make 0x squared. There's no x squared term over here. So I know that a plus b has to be equal to 0 also. But I know b is negative 2. So a plus negative 2 is equal to 0. That's going to mean that a is 2. And now I have all my terms. Like that. Okay, so let's use this and go back and rewrite the integral. So this is equal to the integral of x minus 2 minus, and then we're going to break this down into pieces. So it was 2 over x minus 3, right? Because it was 2 over x minus 3, and we solved a, and a was 2. So 2 over x minus 3 plus bx plus c. So that's a negative 2x plus negative 6 over x squared. Minus because of the minus in front of the whole thing. So this minus right here is this minus right here. So it's a over x minus 3 plus bx plus c over x squared dx. Well, I'm going to be breaking that up into pieces. So let's see, this is x minus 2 minus 2 over x minus 3. Minus a minus 2x is actually going to make plus 2x. And it's 2x over x squared. So that's actually just 2 over x because the x's will cancel on that term. And then minus a minus 6 is plus 6 over x squared dx. I mean, if you want to take a step, you can actually do this, write x over x squared, and then write it again. Oh, sorry. So it's 2 over x minus 3 plus, and then 2 over x plus, and then this would be 6. And thinking about what I have to do, I'm going to write that as x to the negative 2 because I'm going to have to integrate it. These two integrate with natural log. That one actually needs the adding the power. That's a power rule one. All right, so now let's just do this. The integral of x is x squared, or 1/2 x squared, minus 2x minus 2 natural log absolute value of x minus 3 plus 2 natural log absolute value of x, and then minus 6 x to the negative 1 plus c. And there it is. Now, if you want to kind of clean it up a little bit, it's 1/2 x squared minus 2x. These two would be the natural log of x over x minus 3, right? Because this is subtraction, that's addition. But it'd be x squared over x minus 3 squared, an absolute value. This squared comes from the green 2. That 2 right there is squared. And then, if I could write the 2 without it being weird. Sorry, that's a 2. And then this 2 right here would be like that. And then minus 6 over x plus c.